We on here? Yeah, okay. Hi there. Thanks, everybody, for coming. Actually, I just wanted to mention that if you remember in Simon's talk, he had that diagram where he mapped all the companies in the Bay Area to see where they were in terms of using open as a strategy. And Netflix was one of those, and we were in that top right bubble, so I was quite proud of that. But that was, I got to know Simon a few years ago as we were all talking about cloud and all this innovation stuff. And I'll get back to him a little bit later at the end of this. So let's just do a quick intro to myself. So this is from a little while ago. This is kind of what my world has felt like for the last few years, going around talking to people a lot of the time, baffling them with like, well, we do all this stuff, and people go, well, how do you do that? That doesn't look anything like the stuff we do. And I've spent a bunch of time doing this when I was at Netflix in 2010 through 2013. And Netflix gave me a platform that was effectively the ability to go out and talk about the Netflix architecture, what we were doing, and we had a few reasons to do that. But then we'd have lots of enterprises coming and talk to us and say, well, can you come and talk to us about this? And after a while, we're going to what's the value of Netflix talking to some random enterprise in the world about how we do things? We're not really, there's nothing really in Netflix in that. We weren't learning anything from it. So they still do it occasionally, but it was clear that there was a lot of demand for this kind of input and this kind of discussion. So at the beginning of 2014, I moved to Battery Ventures, and part of that was so that I have a bigger platform, because Battery Ventures wanted me to go out and build a network of interesting people that were with interesting problems to solve, so that we could then go and find startups to help solve those problems. So I spent almost 3 years really trying to find all of the most interesting large enterprises, find where they were struggling, find what startups they were working with, what technologies they were moving to, and trying to sort of map all the evolution in that area. And then about a month ago, I left Battery Ventures and joined AWS. So I'm now, this is my 4th week, I think, at AWS, which has an even bigger, broader platform, because we are really effectively sort of the arms supplier for this entire sort of transformation. If you look at an industry, you see, okay, yeah, it's time for this industry to go through that migration, the digital disruption, and then somewhere underneath there you have AWS is providing the cloud for most of what's happening. So it doesn't really matter what industry, it doesn't matter what country you're in, what geography, what type of size of business. It's become a very universal platform that we're building things on top of, plus an innovation platform for building lots and lots of things on top of that. The area that I'm going to be concentrating on for AWS is particularly reaching out to companies that are cloud native or all-in sort of kind of companies, the ones that are pushing AWS to the limit, like trying the latest things that we've come up with, asking us for things we don't do yet. I'm trying to engage at that level, right, and push the architecture as much as possible. And I have an additional specialization, because when you look at those kinds of customers, there's an interesting characteristic. Most of them are in that top right corner of Simon's little diagram, right? They're using open as a strategic advantage. They have open source programs, they have open APIs, they have open data. So I'm going to be running an open source office for AWS. And we're going to be particularly trying to engage with customers around their open source programs. So one of the things I did at Netflix was the Netflix open source program. I came up with the idea, convinced management it was a good idea, branded it, ran it, promoted it, and sort of program managed it, project managed it, and sort of product managed it. But there was never really any of those. None of those are my job titles. That's what just one of the contributions I made. 3 years later, there's like 200 projects in this thing, and it's become a major piece of of the industry. But if you look at it from AWS's point of view, AWS helped a little bit with Netflix OSS, but didn't really engage heavily with Netflix around the open source platform. So we want to kind of set up an ability on the AWS side to go and do that with customers that are building open source so that we can work with them on the open source layering that sits between AWS and its customer base. So that's, this is still an early stages. We're just starting this, and that's kind of the thesis. So that's where I'm going. All right, so that's enough about my latest job change. This is basically a presentation that I've done a few times, and it's really got nothing. The rest of this has nothing to do with AWS. I'm not representing AWS in this presentation. But anyway, so I'm going to talk about simplicity and what do we mean by simplicity, because as managers, we get to say, well, let's make something simple, right? You get given a big problem, you break into simpler problems. So what do we mean by simplicity? Let's develop a more nuanced view of what's going on here. So here's a complicated question. What's the meaning of the life, the universe, and everything? So what's the answer to this? You don't know? Yeah, that's actually a fairly simple answer, right? So so we got to realize the most complicated questions you could possibly have, and somehow we decided there was a simple answer to it, and a very useful logo to put next to that. So there's something different in what do we mean by things being complicated? And what happens is that life and the things we're dealing with are complicated. Lots and lots of moving parts, but we use simple abstractions to deal with it. And what we tend to think if we say something is complicated is it means we can't intuit its behavior, right? It's got two moving parts. We're not sure what it's going to do next. Those are the things that look complicated. Once you've figured out the internal behavior of something becomes predictable and well understood, it stops looking complicated. Right? So there's some interesting sort of evolution here. So somebody says something's too complicated, then you stop and think, is it too complicated, or have you just not figured it out yet? Or is it inherently a very chaotic, complex thing that you're dealing with? Like the weather is sort of simple. Is it going to rain today or not? But underneath that is one of the most complicated things, complex things, impossible to predict on long time scales, right? So what's the most complicated thing that you can intuitively deal with? Any thoughts? Something that's it's a really, really incredibly complicated thing, and we expect just about everybody in society to be able to do. Yeah, drive a car, right? It's horrifically dangerous. It takes a while to learn how to do, but pretty much you have to be fairly disabled to not be able to drive a car. Just about anybody in the world that figures out how to drive cars. I mean, it's with varying amounts of success and danger and whatever, but if you take somebody that's never seen a car before, has no idea, and you sort of sit them in a car and say, okay, drive across London, and it's like, well, first of all, you don't know how to operate this machine. You don't know what the protocols for all the interactions. You don't know how to navigate. You don't understand road signs. There's so many layers of complexity here. And quite often, you can get in your car at home, and you suddenly turn up at work, and you have no recollection of driving. Right? You had that experience. It's like you're totally intuitively, you're just doing the thing. I have a friend who has a Tesla Model S, and we went away last weekend. And we were sitting in a traffic jam coming back, and I put it in automatic driving mode and automatic following mode and just totally ignored the car and the traffic around us. It just followed the road, followed the car in front, and we had about 20 minutes in a traffic jam because it's Sunday afternoon trying to get out of Napa Valley was the problem, and the roads are jammed. And it just followed. I didn't have to think about it. So, but you can do that kind of autopilot thing as well, right? But you do have to pay a bit more attention. So yeah, that's something you can do intuitively. What's another thing that's incredibly complicated, but which requires almost no effort to learn, right? I mean, you can think about a smartphone or a tablet. You can give it to a 2-year-old that can't read, probably pre-verbal. They can reach inside, they touch the glass screen, and they reach inside it, and they start manipulating the user interface. It's one of the most intuitive things that's ever been built. It's quite amazing. But if you look at what is inside an iPad or an iPhone, it's horrifically complicated. They're extremely complex things. and then if you give your phone to somebody else, this is what my home screen looks like. And it's like, you can't figure out how to use my phone. Well, my wife can't figure it out. I can't figure out her phone because our icons are all scattered everywhere, and we have all different applications on them. There's an interesting book, Randall Munroe, Thing Explainer, Complicated Stuff in Simple Words. He took the 100 most common words in the English language, because 1,000 isn't one of them, and he describes exactly how a phone works and how all kinds of other things work just using the 1,000 most common words in the English language. And if you've got, this is a great Christmas present for children and whatever, because it goes through, explains, global warming and tectonic shifts and, or plate tectonics and how to build space rockets and mobile phones, all in these simple words. And just trying to think about all these things. What is the nature of simplicity and complexity that we're dealing with here? And how can we take this? So this is in our lives, right? These are the things that we deal with in our lives. Now, if we move on a little bit and say, well, beyond our lives, there's what is the complexities we deal with at work? And then I'll talk a bit about complexity in the things we build. So how do we simplify the way we organize ourselves at work? Well, one of the interesting things that happened while I was at Netflix is we published this document. We actually jointly edited it on offsite. There were a bunch of people sitting around round tables like we are here. And Reed, before the offsite meeting, Reed sent everyone an email saying, here's a document. I'm thinking of just publishing it to the world. Send me your edits and discuss it, and we'll discuss it at the quarterly offsite. So we all went off, and we figured it out, and we argued about whether we should do it, and what we should put in it, and what we should leave out. And he combined all of those edits together and published this document. I think it's actually gone up to 15 million views on SlideShare of a PDF. It's like 15 million views of a PDF on SlideShare. It's kind of insane. But and then Sheryl Sandberg said she thought it was so interesting and so important that in the end, Reed got a position on the board at Facebook, I think, partly out of that. It's maybe not the only reason, but it's one of the reasons that they cited when he signed up for it. So what has this document got in it that's so radical? And it's because Netflix is a systems thinking culture, and it was set up in a very different way to the way most companies are built. And it has different ways of simplifying the ways that it operates. And it comes down to having a high freedom culture, but with responsibility. And there's a bunch of ways you can think about what that looks like. But this is a quote from this is a slide from that deck. If you want to build a ship, don't drum up the people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. All right? Because if you teach them to yearn for the vast and endless sea, they'll go out and they'll build a better boat than the one you would have told them to build. And there will be more, and they will just be, they will just do a better job. They will figure it out. They know more about what actually to do. And this is a quote from a book called The Little Prince, and it certainly turns out that Netflix bought that movie and has it, so you can go watch this with your kids. Sort of a kid movie, but it's an interesting example. So how do you get these, this is the freedom, right, and the responsibility, but what that means for Netflix point of view is that everyone at Netflix thinks about movies and thinks about and TV shows and the experience that we're trying to create for customers. And then you go and figure out your little piece of that and how you're going to make that better. And then it gets modeled in the way people run meetings even. We used to have a staff meeting every week, and we'd spend the first 5-10 minutes discussing what we'd seen. Like, anyone seen any good movies? Anyone seen this TV show? We'd go around the table, and we're getting our heads into brand, right? We're getting our heads into the state of thinking about the things that matter to Netflix as a business, right? And you can use those kinds of techniques in your own business, right? If you're a car manufacturer, you can talk about, okay, anyone seen the latest, car reviews or, some cool thing, what's going on in your industry, right? So there's a little bit about that sort of sets up it sets up a context for discussing things. So then another big piece of this is this idea that if you want to create a high talent density environment, there's a number of things that you have to do. Other than just getting people in, you have to keep people there. One of the observations that's in the culture deck, the Netflix culture deck, is that process drives away talent. And as companies get bigger, they get more and more and more process, and they start to drive away more and more talent, and they end up with sort of people, the best people have gone. You've got people who are good at running processes are what's left. And and you see that, and then if you come in as a startup and you're competing against one of these big incumbents, you're running rings around them because all the good people left and you hired them into the startup. But when you get big again, you tend to slow down and run out. So the challenge that Reed and the Netflix management put in was, how do we scale the company without adding process and without driving away talent? How do we become a big company, but with a very high talent density? So a lot of the culture is around that. So there's some simple rules that they put in to create that model. And then I was presenting to a CIO, CTO summit, and somebody said, it's about all the Netflix open source things we've done. They said, well, we can't copy Netflix because you have all those superstar programmers and we have normal programmers. And I looked around the room and said, well, we hired them from you. They all used to work at, the companies that were in the room represented most of the places that we'd hired them from. We didn't have like a cloning machine that sort of, took jelly and goop and produced Netflix engineers out of thin air. They all worked somewhere else. And they were reacting to these big companies that had got in their way and taken their, the sort of soul-destroying projects where they used to have to go build this boring thing and it takes forever and you work on something here and maybe a year later it finally reaches a customer. So they turned this around at Netflix where you have a very rapidly evolving product where you do something and customers maybe see it a week later or a few weeks later. You're very much more tied into the feedback loop. That's much more rewarding, and working with stunning colleagues because all the good people are there and you get out of their way and let them tell you what they need to do. So this quote has been copied around quite a bit by people because the trick here is that how do you hold on to the best people in your company? And I did a talk last week at the DevOps Enterprise Summit about sort of top talent and how do you retain it? And that video will be up soon if you want to go find it. But talking about sort of, do you create distinguished engineer programs? How do you get your critical people and motivate them to stick around and not be burnt out and driven out of the company, basically? And then we get to Conway's law. So there's a structure in the company which really controls how it behaves and what it builds. And if you start fighting that structure, then it's very difficult to get things done. It turns out that the structure that we'd already come up with at Netflix was a very cellular-based structure. To some extent, we copied the sort of Amazon two-pizza team idea, but we were already doing things in that way. So it was very natural, and we ended up building this microservices architecture because it fitted the way our culture was. Now I see people trying to adopt microservices, but they've still got their silo-based system. So this team is going to build a microservice, and we're going to have the developers in this country and QAs over here, and then the people operating the microservice in yet another country. Don't do that. It doesn't work. It never comes out well, right? What you need to do is take each team and say, okay, what kind of microservices should you run at this location in this country? Maybe there's a team that's sort of very pioneering and they build the latest, newest things, and that's the hottest technology piece. There's another team that likes to maintain and extend things, and maybe there's another team which you want to just farm out maintenance of fairly stable pieces of software, but you still have to add security patches and maybe fix bugs in it. But the ownership of that microservice moves between those teams. But each of those teams owns everything about it. They own all the updates, and they own operating it, and they own everything about it. So that's one way of organizing yourself. So don't fight the structure. So the trick here, that one of the ways to simplify the way you organize work is to set up the organization structure so that the systemic feedback loops cause the right outcomes, cause the right architecture to happen. There isn't really an architecture diagram for Netflix other than the org chart for the teams that are building things. That's the nearest thing you get to a systems architecture. So what you're trying to do here is build a systems with feedback, because systems are relatively easy to understand. They're flexible. You can apply them to new situations, whereas processes tend to be fairly rigid, and they're complex to learn, and they tend to break when they come across a situation that they haven't seen before. So that's typically the approach at Netflix, was to try and not have too many processes and try to effectively have systems. So one example would be, we took our developers and we said, you're just going to be on call for your code, right? You're going to operate it, you're going to deliver it to production, you're going to be on call, you're the first line support for your code, for your microservice. We're going to break the system into lots of different small services, so you're not on call for stuff that 100 people wrote. You're only on call for the thing that you wrote most of that, right? So that's breaking it into small chunks. But then because they were on call, they started thinking, you know what, I'm not going to push code on a Friday afternoon because I want to go somewhere this weekend. I'm going to find a buddy that I'm going to code review with, and I'm going to do a deal that they'll look after my code for a week and I'll look after their code for a week. So we ended up with sort of pair programming and good operational hygiene without having a process to do that. We just created the feedback loop that made it obvious that these were techniques which you could use to survive the fact that you were now first-line call for your code. Right? So people it turns out developers can write really reliable code when they're on call for it if it breaks. And if it does break, they know exactly the state it was in and how to fix it, so the time to fix is really short. If you keep trying to hand off code to somebody in operations, because in theory they're sort of specialist at that, and maybe, you know, what you find is the handoff is incomplete, so they can only solve simple problems because they have to call the developer anyway a lot of the time. And they also, you can only do it so often. If you're pushing code 10 times a day, you can't have 10 meetings with operations about what you're currently doing, right? You have to have some sense of context that is updating, that can be updated as fast as you want to go. So this comes down to, this is one of the most fundamental things, and you can think about DevOps as a recent term. This is the original idea behind DevOps from the Netflix point of view. If you build it, you run it. It's the way AWS works, it's the way Amazon.com works, and it's the way that one of the things Netflix copied out of that, and it's part of the whole DevOps movement now, is much more about building it and running it. And that's the developer end of the DevOps spectrum. There's also another end, which is like if you're an operator, what you do with DevOps is you build a platform that's API driven, and self-service, which is sort of a cloud, really. Cloud is self-service API driven infrastructure. So think of it in that sense. Okay, so I talked about simplifying the way we work. So let's look at simplifying the things that we build. One of the big moves that we're looking at right now is a lot of the work we've done up to now has been project-based. You know, we've got their big SAP system. It's time to upgrade it. So we'll form a project team, and they'll work on that for 9 months. And after 9 months of that, they'll want to run away, right? So then they give it to operations, run away, and then you're stuck with whatever state it was in for the next year or two, right? So that's kind of the project-based mentality. But if instead you say, instead of a project, I'm going to have a product. I'm going to have a product team that owns a thing, and break your system into smaller chunks. Now, because you own the product, you own the evolution of that product. You own it's continuously evolving. And because it's continuously evolving, there is no start and end for the project. It's just getting slightly better all the time. And you don't get locked in. You're not locked into, this version of, say SAP runs on this version of Oracle or something like that, and we're locked into that contractual thing until there's another project to migrate it to something else. If you have a team that owns ERP and they own the ERP as a product, they can keep evolving it, they can keep changing it, they can design out, and one of the features they could add in one of their sprints or whatever you want to call it is that they could change a dependency. They could plug in a different database, or they could do incrementally work towards the ability to do a migration. So you're not doing getting locked into something and then having these sort of Herculean rebuilds to get off it, you're continuously unlocking and relocking. And I have a talk I did on lock-in, so I'll just sort of digress slightly. And I asked the question, so who here doesn't like lock-in? It was mostly an operations audience. They all put up their hands. And I said, so are any of you married? And they went, yeah, so, okay, so lock-in's not bad all the time, right? And then so this was at the time that Ashley Madison website was in the news. So we'll look up the people that don't like lock-in and are married on Ashley Madison, see if you're in that database to find out. So the observation I made was that developers are the people locking in. It's like the developers go on dates and get married, then they hand over to operations to run the family and get divorced. Now, why don't operations people like lock-in? Because they're the people getting divorced, right? They're not the people getting married. And let's say, some of you probably have experienced this. It's much more fun to get married than it is to get divorced, right? So by taking away that handoff, and having it that developers run the whole thing beginning to end, they think more carefully about the technologies that they get locked into and how tightly they're locked into them, and they continuously unlock themselves, right? And that way, you don't have so many painful divorces in your infrastructure, right, that you're trying to deal with, and because you own the whole thing end to end. So that's another reason for doing it that way. And that's why you have project teams, product teams, because they're now able to evolve what they're doing continuously on business inputs, technology inputs, market inputs are just another thing to optimize for, rather than trying to sort of form a team and have them walk away from it at the end of the project. The other thing that we want to optimize for is time to value. There's nothing more sort of soul-destroying than writing a line of code and then having it, a year later, you've probably even left the company before it reaches the customer and does something. And then there's a bug in it, and you can't find the person that wrote the code, and nobody cares. And so the more you shrink that, the happier people get, and the more productive they get, and the more context you have for your ability to iterate and learn. Because the point here is you're going around that OODA loop that Simon talked about, and you're learning. Every time you go around that loop, you learn something about your customers, your markets, or your technologies. If your loop takes a year, it takes you too long to learn things. If your loop takes a week, you can learn lots of things. If you break your application from a monolith, where you learn one thing each time you push out the monolith, to lots of microservices, maybe 100 microservices, each microservice is learning something every week, right? So you're running in parallel, you're learning a lot in parallel, and the domains are small enough that you can rapidly move forward. All right, so just got a few more slides and I'll wrap up. So one more thought here is that you want to optimize for the customers that you want to have if you're growing your business, as opposed to the customers you've got. We say customers are always right. Well, the best customer is the one that has not quite bought your product yet, but is about to, right? If you think about selling SaaS products where it's retention-based business, it's the conversion from free trial to paying customer. That is the point at which you want to optimize. Right? That initial retention of free trial people. If you optimize for that, you're actually optimizing for customers who've never seen your product before to want to sign up for it. Right? And that's actually, it's a kind of a deep insight into the thing Netflix optimizes for in the way they build their business. And when you're doing these hypothesis testings, you're saying, what is the thing that will create, that will cause customers to become sticky, right? Now, if you look at your existing customers and optimize for them, you end up building Word, right? Because the existing customers want power user features, and those power user features make the product harder to understand, and it makes it harder to acquire new customers. So this is one of the traps you need to avoid. Okay. And then there's this thing, sort of monolithic versus microservices. And monolithic apps, they look, deceptively simple when you draw them on the architecture diagrams. You have one big blob that does everything. But if you look inside that, there's a big, there's various words for it, ball of mud, tangled spaghetti code. There's a bunch of very, very highly complex things going on inside those monoliths, which is why it's so hard to update them, why it's so hard to modify a monolith, and why we want to break it into microservices. But the relationships between the microservices make the complexity more visible, and it looks more complicated, but the overall complexity is actually lower because you've created very well-defined interfaces between all of your components. So think about, people saying microservices are more complex. They're actually, in many ways, simpler. The complexity moves to a different part of the system, but in terms of the architecture, they're actually simpler than what was actually going on inside your monolith. And it's this separation, the enforcement of that separation, that actually makes them less complicated. So there's a few architectural principles here. I like to find symmetry in things because that makes things simple. Yeah, like if you look at globally distributed web services, if every region is the same and every zone is the same, like the way Netflix works is 3 zones and 9 regions. The same code is in all 9 places. The same data is in all 9 places. You can lose an entire zone, a data center. You can lose an entire region. The service keeps running. Right? Now, there's ways you can optimize it so that you don't really need a very expensive disk subsystem anymore because your data is replicated in so many places that you don't have to worry about a lot of failure modes. So you can run on lower cost commodity systems because you've got so much replication, but you're basically taking the replication up into the application architecture. So that symmetry gives you invariants, which lets you make assertions that say, I can service a customer from anywhere in the world, right? And that means if I need to evacuate a region, I can. And this all comes down to a systems thinking approach, which gives you that too. All right, so a little bit about where we're going next, and I'll wrap up. This is my favorite quotes from, this is actually one of the hardest things in this, is pronouncing his surname, Jamshid. And someone said garage doggy, right? Think of a garage with a doggy in it. So garage doggy. So I've met him, and that was as near as anyone can get to. That was what his family said how to pronounce the name. So this is one of the the key books on systems thinking. This book explained a lot of things. Sometimes you come across a book and a whole lot of things you've been looking at for decades suddenly click into place. This book is one of those books for me. It laid out the history of systems thinking over the last 50 years. So we see the world as increasingly more complex and chaotic because we're using inadequate concepts to explain it. When you understand something, it no longer seems complex and chaotic. Right, and if you look at the way that a company like Netflix operates, it looks very chaotic because everyone's running around. There isn't a big central plan. But what there is there are some central systems. There are some feedback loops. There's some behaviors that everyone is modeling. And it's actually a very simple system to manage. But you're managing it by creating these incentives, feedback loops, and systems rather than telling people in a hierarchy exactly what they should do with processes. So Simon was up earlier, and I like my very, very boiled down version of all the stuff Simon tells you is you can go through these phases. There's sort of an innovation phase with technologies that we're dealing with. Some things we're in a leverage phase, and some things we're in a commoditize phase. So let's just look at the innovation stage. There are a number of technologies we're dealing with, and you can tell they're in this phase because people are still arguing about the words. Right? Serverless right now. You go into a room and start talking about serverless computing, and you'll get all kinds of arguments going. That's because it's in this pioneer innovation stage. The concepts are still poorly defined. Pioneers are adopting it, but the mainstream still haven't figured out what is all this stuff you're talking about. Right? The next one, there are stages where the concept is now well understood. Except containers is probably here right now. Pretty much everyone's figured out what container is. 2 years ago, we were still arguing about it. But now, okay, we figured out what containers are, but now, which container orchestrator should you use? There's too many choices, and it's all a big mess. But we're really at the point now of there's lots of competing implementations, and there's mainstream adoption of the core concept, right? Containers are pretty mainstream now. How container schedulers are there's a big bun fight. Everyone's arguing about it. And then the commoditized stage, at this point, you've got lots of compatible implementations. They're all as a service. You really care more about what's the quality of that service, right? What's the cost? What's the availability? It's all of maybe the non-tangible things. They all have similar Everyone has agreed that this is now something that everyone should do, and you can buy it from lots of places, and it's sort of interchangeable, right? And that is then the base for the next innovation. You build up, and you kind of, once you've figured out this is commoditized, like maybe, platform as a service, the Cloud Foundry kind of things. It's kind of become a commodity. You can buy it from multiple vendors. If you want to stand up a simple website, just don't go and design your own platform architecture. Just take something off the shelf, treat it as scaffolding, go build on top of it, and just get on with building whatever innovation you were trying to build on top, right? So that's the kind of idea we're looking at here. What is something that's pre-built scaffolding? Like if you want to stand up a website, don't start by writing lines of code. Start with Ruby on Rails or something like that, some simple thing, right? Those are the scaffolding concepts that mean that all of the conventions, you just adopt them and build to the next layer, right? So those are the things that we see which are really commoditized. All right, so that's what I got.
Very good.
Okay.